Is the population here still safe? Most people here remember what happened in 2006. The ground shook without warning. Homes collapsed in seconds. Entire neighborhoods were reduced to rubble. More than 5,000 people were killed. And for many, the memory never left. Because that earthquake did not begin with chaos. It began in silence. Beneath this island, something enormous is happening. Not an earthquake, not an eruption, something slower, something far more dangerous if ignored. While millions of people go about their daily lives, the ground beneath them is quietly locking into place. And when tectonic plates lock, they do not forget. They store energy. Java sits on one of the most dangerous geological boundaries on Earth. Here, the Indo-Australian plate is being forced beneath the Sunda plate, not slipping smoothly, not releasing pressure gently, but grinding, catching, locking. And this single process has shaped some of the most powerful earthquakes the planet has ever produced. Earthquakes do not begin with shaking. They begin with silence. Years of it. Sometimes centuries. Stress builds 1 millimeter at a time, far below the surface. And nothing on the ground tells you when that balance is about to change. That is why scientists are watching Java so closely. Modern instruments have revealed something unsettling. The plate boundary beneath Java is not behaving uniformly. Some sections are creeping slowly, others are completely locked. This uneven movement matters because where plates lock, stress accumulates. And where stress accumulates long enough, large earthquakes become possible. Let's stop here for one critical clarification. This is not a prediction. No scientist can say when an earthquake will happen. There is no countdown. What science can do is identify systems under strain. Java is one of them. To understand why, you have to zoom out. Subduction zones are the most powerful earthquake factories on Earth. They are responsible for every magnitude 9 earthquake ever recorded. Japan, Chile, Sumatra. Java sits on the same type of boundary. The physics are identical, only the location is different. In 2006, a powerful earthquake struck near Yogyakarta. More than 5,000 people were killed, tens of thousands were injured, and yet that event only released a portion of the stress stored along the fault. It was not a full rupture. Which raises a difficult question: how much energy remains? Today, scientists use tools that did not exist a generation ago. Continuous GPS stations measure ground movement down to millimeters. Satellite radar detects slow deformation across entire regions. Seismometers capture vibrations too small for humans to notice. Together, these instruments reveal something counterintuitive. Not all earthquakes happen suddenly. Some begin slowly. These slow movements are called slow slip events. They occur deep underground. They can last weeks or even months. They do not cause damage. They do not produce shaking, but they move tectonic plates anyway. And when they occur near locked fault segments, they change the stress balance, sometimes relieving it, sometimes transferring it, sometimes increasing it elsewhere. Beneath parts of Java, slow slip behavior has been observed, not constantly, not everywhere, but often enough to demand attention. This does not mean a large earthquake is imminent. It means the system is active, and active systems deserve respect. Some of the most dangerous faults on Earth are quiet. They do not produce frequent small earthquakes. They remain locked for long periods of time. Then they release everything at once. This is known as a seismic gap. And parts of the Sunda subduction zone show characteristics of one. A seismic gap does not guarantee disaster, but history shows a pattern. Where stress accumulates without release, large earthquakes become possible over long timescales. Java lies adjacent to one of the most densely populated regions on the planet. More than 100 million people live within reach of this boundary. Java is also one of the most volcanically active regions on Earth. Over 100 active volcanoes line the island. These volcanic systems interact with tectonic forces in complex ways. Magma movement alters stress underground. Earthquakes can change magma pathways. One does not cause the other directly. but they are connected through pressure. Scientists are careful to avoid sensational conclusions. Volcanoes do not predict earthquakes. Earthquakes do not automatically trigger eruptions, but both respond to the same tectonic engine, and that engine beneath Java is powerful. The Sunda megathrust is capable of producing earthquakes exceeding magnitude 9. This is not speculation. A neighboring segment ruptured in 2004 during the Sumatra Andaman earthquake. That event released more energy than any earthquake recorded in over 40 years. It permanently altered Earth's rotation, and it did not rupture the entire fault. Large sections of the megathrust remain unbroken, including segments closer to Java. This does not mean another massive earthquake is coming soon. It means the system is incomplete, and incomplete systems remain under study. So what exactly are scientists watching right now? They are watching how fast the plates are converging. They are watching how much of the boundary is locked versus creeping. They are watching how stress migrates after regional earthquakes. They are watching how the system responds over years, not days. One of the most important tools is probability modeling, not prediction, probability. Based on historical earthquakes, plate motion rates, and fault geometry, scientists estimate long-term risk. For Java, that risk is not zero, and it never has been. High risk does not mean imminent danger. It means preparedness matters. Early warning systems save lives. Building codes determine survival. Public awareness changes outcomes. The earthquake itself is only part of the story. Japan did not eliminate earthquakes. It reduced casualties. Chile did not stop tectonic motion. It improved resilience. Disaster is not determined by nature alone. It is shaped by preparation. Right now, scientists are not issuing alarms. They are refining models. They are installing more sensors. They are improving tsunami simulations. They are reducing uncertainty. But uncertainty never disappears completely, especially in systems as large as Earth's tectonic engine, which is why places like Java are monitored continuously. Not because disaster is certain, but because the consequences are enormous. Is the population here still safe? The honest answer is conditional. Safety depends on understanding, on preparation, on listening to signals long before the ground begins to shake. Earth does not fail without warning. It communicates, quietly, slowly, through signals most people never feel. And beneath Java, those signals are being watched carefully. Not to predict the future, but to understand it. This is not a prophecy, it is a reminder. The planet is always moving, and the question is never whether the ground will change. It is whether we are ready when it does. What makes subduction zones like this especially dangerous is time. Stress does not build evenly, it concentrates. Tiny variations in rock strength, temperature, and fluid pressure determine where energy is stored. These details are invisible at the surface, but deep underground, they decide how an earthquake will unfold. This is why two earthquakes on the same fault can behave very differently. One may rupture slowly, another may tear through hundreds of kilometers in minutes, and scientists cannot know which outcome will occur until it happens. This uncertainty is why monitoring never stops. Every new data set slightly reshapes the picture. Every year of accumulated measurements reveals patterns that were impossible to see before. In recent decades, researchers have discovered that stress can migrate. An earthquake in one region can subtly alter the pressure field far away. Not enough to cause immediate damage, but enough to load or unload neighboring fault segments. This means tectonic systems do not fail in isolation. They behave like networks. A change in one place can influence another. This is particularly important in Indonesia, where multiple major fault systems intersect. The Sunda megathrust, crustal faults beneath Java, and deep seismic zones within the subducting plate itself. All of them interact. All of them respond to stress. Another factor scientists track closely is friction. Faults do not slide freely. They resist motion. And the way friction behaves under pressure determines how energy is released. Some faults weaken as they begin to move. Others strengthen. This difference separates slow deformation from violent rupture. Laboratory experiments, combined with real-world observations, help scientists understand which sections of a fault are more likely to lock. But even with modern tools, the picture is incomplete. That is why probability is the language of hazard science, not certainty, not prediction, probability. Over long timescales, the statistics are clear. Large earthquakes happen, they always have. What changes is how societies respond. In regions where earthquakes are rare, memory fades. Buildings grow taller, populations increase, risk quietly grows. Java is not a place without memory. Earthquakes are part of lived experience, but memory alone does not reduce risk. Preparation does. Education does. Investment does. This is why scientists, engineers, and emergency planners work together. Not because disaster is inevitable, but because it is possible. Early warning systems do not prevent earthquakes. They provide seconds, sometimes tens of seconds, but those seconds matter. Trains can slow, gas lines can shut, people can take cover. In past events, those seconds have saved thousands of lives, and they are only possible because scientists listen to signals long before disaster strikes. Beneath Java, those signals continue, quiet, persistent, unimpressive to the untrained eye, but to those who study them, they tell a story not of panic, but of process, of forces that shape continents, of systems that operate on timescales longer than human lives, and of the responsibility that comes with understanding them. Because knowledge does not eliminate risk, it changes how we face it. And in places like Java, that difference matters more than anything else.